When the weight of the multirotor is increased due to the loading of the cargo or etc., the average thrust of the propellers for cancelling the gravity increases. At this time, if the average thrust is close to the maximum thrust, the thrust required for the specific motor may exceed in the maximum thrust when generating attitude control torque for horizontal motion. To solve this problem, we developed a new type of multirotor named tilting thruster type multirotor or T3 multirotor. The new platform is equipped with mechanically separated thrusters, which can take any fuselage posture within a specified range, regardless of any direction of translational acceleration. A specially designed servo-linkage mechanism is employed for relative attitude control between the thruster and the fuselage. With the T3 multirotor, only a small amount of torque is required because only the thrust generation part needs to change the attitude for horizontal force generation. Therefore, individual motors are less likely to exceed the maximum thrust even under high average thrust conditions. For this purpose, the study aimed to find an independent attitude control method of TGP and FP. The goal of this study is to find a way to overcome the underagitedness of the fuselage part by studying the method of independently controlling the thrust generation part and fuselage part's attitude by building the platform and analyzing the dynamic characteristics. First demonstration is the circular flight. The experiment is designed for the multirotor to follow the circular path. The experiment is carried out twice. In the first experiment, the relative attitude between the thrust generation part and the fuselage part is fixed like a conventional multirotors. In the second experiment, the fuselage always maintained a level regardless of the movement of the thrust generation part. For more information on dynamics and relative attitude control, please refer the article. Second demo is slope takeoff. Conventional multirotors are not capable of stable takeoff due to the possibility of part of the aircraft colliding with the ground because of the attitude control overshoot due to non-zero initial condition when taking off from a sloped place. However, since T3 multirotor can control the relative attitude between thrust generation part and fuselage part, the initial condition of the thrust generation part's attitude can be adjusted to zero regardless of the slope, and stable takeoff is possible.